At this point, you know how to write complex queries. You know how to simplify these queries by saving them in views. And you also know how to insert, update, and delete data using SQL statements. Now, let's say you're building an application that has a database. Where are you going to write these SQL statements? You're not going to write them in your application code for a couple of reasons. One reason is that it will make your application code messy and hard to maintain. For example, if you're building an application with C# or Java or Python, you don't want to mix your Java code with SQL because the SQL code gets in the way and it makes your application code look messy and hard to maintain. Also, some programming languages like C# or Java require a compilation step. So if you write your SQL queries in your application code and then find out that you need to change one of your queries, you'll have to recompile your application code for these changes to take effect. So every time you make a change in your SQL code, you will have to recompile and potentially redeploy your application code. For these reasons, you should take your SQL code out of your application code and store it in a database where it belongs. But where? Inside a stored procedure or function. So a stored procedure is a database object that contains a block of SQL code. In our application code, we simply call these procedures to get or save the data. So we use stored procedures to store and organize our SQL code. But stored procedures have other benefits. Most database management systems perform some kind of optimization to the code in stored procedures. So the SQL code in stored procedures can sometimes be executed faster. Also, just like views, stored procedures allow us to enforce data security. For example, we can remove direct access to all the tables and allow various operations like inserting, updating, and deleting data to be performed via stored procedures. Then we can decide who can execute which stored procedures, and this will limit what the user can do with our data. For example, we can prevent certain users from deleting our data. So stored procedures are very powerful, and in this section, you're going to learn how to create and use them. So let's get started. In this lecture, you're going to learn how to create a stored procedure in MySQL. For this demo, we're going to write a simple query, like select everything from the clients table. We want to store this query in a stored procedure. We can create a stored procedure using the create procedure statement. Then we give our stored procedure a name, like get underline clients. Note that here I'm only using the lowercase letters and I'm separating multiple words using an underscore. This is a common convention amongst MySQL developers. Now, after the name, we add a pair of parentheses. Later, I will show you how to add parameters here to pass a value to our stored procedure. Then we type begin. Here's our query, and then we terminate the stored procedure using the end statement. What we have in between the begin and end keywords is called the body of the stored procedure. Now here we only have a single statement, but quite often the stored procedures that we create in the real world have multiple statements. So we'll have to terminate each statement using a semicolon, even if we have a single statement here. This is a MySQL requirement, and you may not have to worry about this if you use other database management systems like SQL Server. Now here we have a couple of syntax errors. Don't worry about it. We're going to fix it in a second. Now here's the tricky part. We want to give all these statements to MySQL as a single unit, rather than individual statements separated using a semicolon. So we want MySQL to take this entire unit and create a procedure for us called getClients. We don't want it to execute individual statements that we have here. How do we do this? Well, we'll have to change this default delimiter, that is a semicolon, to something else. So just before creating our procedure, we use the delimiter statement to change the default delimiter. By convention, a lot of developers use $2, but you can literally use anything. You could use 2 slashes or any sequence of characters that you don't use in your SQL code. But let's stick to the convention. So we add $2 here to change the default delimiter. Then we repeat this after the end keyword. So with this, we're telling MySQL, hey, this is the new delimiter. Take all these statements as one unit. Now, finally, we need to change the default delimiter back to a semicolon. So with these changes, you can see those syntax errors are gone. This is how we create stored procedures in MySQL. In other database management systems like SQL Server, you don't have to change the default delimiter, okay? Now let's execute this. All right, now let's open up the Navigator panel, refresh the view. Now we have a new store procedure, beautiful, get clients. We can call or execute this procedure by clicking on this icon. This returns all the clients in our database. We can also call a store procedure using the call statement. So call get clients, then we add the parentheses, and this executes our get clients stored procedure. Now, most of the time, calling a store procedure is something that we do in our application code, like in C#, Java, Python, whatever. But there are times that you want to call a store procedure in your SQL code, and this is how you do it. Now, for your exercise, create a store procedure called get invoices with balance to return all the invoices with a balance greater than 0. All right, before creating the store procedure, let's first write this query to make sure our query returns the right result. So select everything from the invoices table where invoice total minus payment total is greater than 0. So these are the invoices. Now here we could also use our view. So I can select everything from invoices with balance where balance is greater than 0. Okay. This is better because we can see the balance column here. So all these invoices have a balance greater than 0. Beautiful. Now let's put this inside of a store procedure. So first we need to change the default delimiter to $2. Then we create a procedure called get invoices with balance. We add a pair of parentheses. Then we add begin. It's better to indent our code so we know where our store procedure begins and where it ends. Now here we need to type the new delimiter, $2, and then we need to change the default delimiter back to a semicolon. Here we have a syntax error because I forgot to put a semicolon here. So as I told you before, you should always terminate every single statement in a store procedure with a semicolon. And this is the reason we changed the default delimiter so we can use this semicolon in our store procedure, okay? Now let's execute these statements. All right, back in the Navigator panel, let's refresh. Here's our new store procedure. Let's call it. And here's the result. Beautiful. Now you might think that creating store procedures is very tedious in MySQL because we have to change this default delimiter every time we want to create a store procedure. So let me show you an easier way. Here in the Navigator panel, we can right-click on the Stored Procedures folder and create a stored procedure. Now in this window, we don't have to worry about changing the delimiter. We just focus on our SQL statements. So let's give this new procedure a name, like get payments. As I told you before, MySQL by default adds this backtick character, and this is to prevent a name clash with SQL keywords, okay? So here we simply select everything from the payments table, and we should terminate this statement with a semicolon. Now, here in the bottom right corner, you should see two buttons, apply and revert. As I told you before, unfortunately, they are not visible in my recording window. Just click on apply, and then MySQL generates these SQL statements. So it will take care of changing the default delimiter. We don't have to do it. Then go ahead and click apply. All right, now we have a new store procedure here, get payments. When we call this, it returns all the payments. Beautiful. In this lecture, you're going to learn how to drop a stored procedure. This is particularly useful if you made a mistake and you want to recreate your stored procedure. So we use the drop procedure statement followed by the name of our procedure, like get clients. Let's execute this. All right. Our procedure is gone, so it's not here anymore. Now, if we execute this statement one more time, we get an error because MySQL will raise an error if we try to drop a procedure that doesn't exist. To prevent the error, we can use the if exists keywords. So we change this statement to drop procedure if exists. This is a better and safer way to drop procedures. Also, just like views, it's a good practice to store the code for dropping and creating each stored procedure in a separate SQL file, and then put that file under source control like Git. This way you can share your Git repository with other team members, and everyone can recreate this database with all its views and stored procedures on their machine. So typically, we have the drop statement first, followed by a semicolon, and then create procedure, get clients, begin, and of course, we need to add the delimiter statement here, and also change that to the default delimiter. And then here we can write select everything from the clients table. So this is a basic template for creating stored procedures. Now we save this in a file called get clients. So save. Earlier we created the views folder for our views. Now we can create another folder for our stored procedures. And here we add get underline clients.sql. When you put all these scripts under source control, you can always go back in time and see what changes you made to your database objects at any given point in time. We have learned how to create and drop stored procedures. In this tutorial, I'm going to show you how to add a parameter to your stored procedures. We typically use a parameter to pass a value to a stored procedure, but we can also use parameters to send values to the calling program. We'll look at that later. So here we're using the code for creating a stored procedure called getClients. Now let's create a new procedure called getClients by state. So underline by, underline state. Also, let's change the name here, by state. We want this stored procedure to receive the name of a state and return the clients in that state. So here in between the parentheses, we need to add a parameter. We call it state and set its type to char of 2 in parentheses. Now this looks a little bit unreadable, so we can break this down into multiple lines like this. So after the create procedure statement, we add a pair of parentheses, and in between parentheses, we list all our parameters. If you have multiple parameters, we need to separate them using a comma, okay? Now, what is this char2 here? This represents a string of 2 characters, like CA for California or NY for New York. We also have varchar, which represents a variable length string, and this is useful for storing names, phone numbers, messages. These are variable length strings. Most of the time we use varchar, unless we know that our strings always have a fixed length. In this case, state, okay? Let me delete this comment. Now we'll look at data types in more detail when we talk about database design. All right, we added this parameter here. Now we need to add a where clause to filter the clients. Actually, I realized I made a mistake. This select statement should be after the begin keyword. I hope you caught my mistake. So let's go ahead and add a where clause where state is equal to state. Now this looks weird and our filter is not going to work because we're comparing the value in a column with itself. And of course, this condition is always true. So here we need to separate the state column from the state parameter we define here. There are a few different ways to do this. Some people prefer to prefix or postfix their parameters with something like p underline state, as in short for parameter, or just p state with a capital S. Other people prefer to add a postfix like state underline param. I personally don't like this. I think this is a little bit verbose. So I prefer to use clean names for my parameters. And then instead, here I'm going to give an alias to our table, C. And then we qualify this column with its table alias, so c.state. It's quite clear that we're comparing the value in the state column with the state parameter we defined here. Now let's execute these statements. All right, our procedure is created. Let's take a look. I'm going to refresh the view. Here's get clients by state. So let's go ahead and call this procedure. Call get clients by state. I'm going to pass CA, as in short for California. And this returns the clients in California. Beautiful. Now, what if we don't supply a value. We get an error here because all parameters are required in MySQL. Here's your exercise for this tutorial. Write a stored procedure to return invoices for a given client. Call it getInvoicesByClient and give it the client ID parameter. Now for the type of this parameter, look at the type of client ID column in the invoices table. All right, here I'm going to create a stored procedure in MySQL Workbench. Let's call this getInvoicesByClient. Here we need to add the client ID parameter. What is the type of this parameter? Well, let's have a quick look at the type of client ID column in the invoices table. So that is an integer. An integer, as I told you before, represents a whole number. So back to our procedure, the type of this parameter should be int. Now I'll be right. Our statement, select everything from the invoices table where client ID equals to, well, let's give this table an alias and then qualify our column and complete the where clause. All right. And here's our semicolon. Now let's click on apply. There you go. So MySQL generated all this stuff. Apply. Beautiful. We should have this procedure here. getInvoicesByClient. Let's call this procedure. Now we get this pop-up. We can pass client ID 1. And this returns the invoices for this client. In this tutorial, I'm going to show you how to assign a default value to a parameter. So here we're using the procedure we created earlier, getClientsByState. Now let's make up a rule. If the caller of the stored procedure doesn't specify the state, we want to return the clients in California by default. So here, before executing this query, we can write an if statement like this. If state is null, then we want to give it a default value. And for that, we use the set statement. Set state to California. And obviously, we need to terminate this statement with a semicolon. So if this condition is true, we assign a default value to this parameter. Now, whenever we use the if statement, we should always terminate it with and if. Because if this condition is true, we might have multiple statements here. So we need to tell MySQL what is the end of the if block. Okay. Now let's go ahead and recreate this procedure. All right, our procedure is created. Beautiful. Now let's go ahead and call this procedure with null. So I'm going to open a new query window. And here we're going to call getClientsByState. And we pass null as the parameter. So this returns the clients in California. Note that here we have to specify a value, even null, because if we leave it out, MySQL is going to complain. All right. So let's add null here. Now let me show you a really powerful trick. Back to our procedure, let's change the rule. What if instead of returning the clients in California, we want to return all clients? How can we do that? Here's one way. Instead of giving our parameter a default value, we can write a separate query like this. Select everything from the client table. Then we add an else statement. So if this condition is not true, then we want to return the clients in a given state. So we can move this query up here. Let's fix the indentation. That's better. So we have an if statement followed by an else statement and finally and if. Let's recreate this procedure. All right, now back to our query window. If we don't supply the state, we get all the clients. If we pass a state like California, we only get the clients in California. Beautiful. However, this approach is a little bit verbose and it looks amateurish. We can combine these two queries into a single query. Let me show you how. So I'm going to delete all these if and else statements, as well as and if. So we have the same query we had before. Now I'm going to change the where clause like this. If null, state, comma, c.state. What's going on here? You learned about the if null function in the last section. right? If the first value is null, this function returns the second value. So here, if we set the parameter to null, this function will return c.state, and our where clause will essentially look like this, where c.state equals c.state. This condition is always true because a value is always equal to itself. It's like writing 1 equals to 1. We're comparing the value in a column with itself, right? So let's revert this. With this technique, we can optionally filter data. All right, here's a fantastic exercise for you to practice what you have learned so far. Write a stored procedure called getPayments with two parameters, client ID, which is an integer, and payment method ID, which is a tiny integer. So both these data types are used for storing whole numbers. A tiny integer takes 1 byte of memory, and with this we can store numbers from 0 to 255. Integer takes 4 bytes, and with this we can store larger numbers. Once again, we'll look at data types later in the course when we talk about database design. But if you're curious, you can simply search for MySQL int size. In this table, you can see various data types for storing whole numbers. We have small int that takes 2 bytes of memory, and this is the maximum value we can store in 2 bytes. We also have medium int, which we have seen so far, big int, and so on. So back to our procedure. Both these parameters should be optional. So if we pass null for both of them, our procedure should return all the payments in the database. If we supply the client ID, it should only return the payments for this client. If we set both these parameters, it should return all the payments for the given client using the given payment method. It's a fantastic exercise, and it helps you get ready for a job. All right, here's the solution. Let's create a new procedure. We're going to call this getPayments. This procedure needs 2 parameters. The first one is client ID, which is an integer, and the second is payment method ID, which is a tiny integer, right? Now here we write a select statement to select everything from the payments table, where here we need to type 2 conditions because we have 2 ways to filter data. The first one is for the client. So p.clientID is equal to, once again, we use the if null function. If the client ID parameter is null, we want to use the same value in the client ID column, right? Let me zoom out. All right, this is our first condition. Then we need to apply the AND operator followed by our second condition. p.payment method is equal to, so note that the name of this column in this table is payment method, not payment method ID. As I told you before, this is one of the real world scenarios. When you work with an existing database, a lot of times you see that the name of the columns are not consistent. All right, so you'll have to deal with that. Once again, we use the if null function. If the payment method ID parameter is null, you want to use p.payment method. Once again, it's not fitting on the screen. Let me break this down. All right, better. So this is the final solution. Now let's test it. Click apply and then create the procedure. Beautiful. I'm going to open a new query window and call the getPayments procedure with 2 values, null and null. Now, technically, the values that we pass here are called arguments. A lot of developers don't know the difference between arguments and parameters. Parameters are the placeholders or the little holes that we define in our procedures or functions. So in our procedure, we defined these 2 parameters, client ID and payment method ID. The values that we supply for these parameters are called arguments. Okay. So anyway, back here, let's execute this procedure. So this returns all the payments in the database. Beautiful. What if we pass 1 for the client ID? Now we only see the payments for this client. What if we pass 5? Now it returns all the payments for client number 5. Note that the last payment has a different payment method. So let's filter that too. I'm going to pass 2 for the payment method. And now we only see this record. What if we pass 3? We don't see anything because this client doesn't have a payment using this payment method. All right. And also, as one last test, let's pass null for the client ID and 2 for the payment method. We want to see all the payments using this method. So we only have a single record. So far, you have only seen procedures that select data, but we can also use procedures to insert, update, and delete data. In this lecture, we're going to create a procedure to update an invoice. And as part of this, we'll be looking at parameter validation to ensure that our procedure doesn't accidentally store bad data in our database. So let's start by creating a new procedure. We're going to call this make payment. Here we need 3 parameters. First is the invoice that we want to make a payment for, so invoice ID. And the type of this is integer. The second parameter is the payment amount. And the type of this parameter is decimal of 9 and 2. What is this? Decimal represents a number with a decimal point. Here we have 2 arguments. The first argument represents the total number of digits, and the second argument represents the number of digits after the decimal point. Okay? And finally, the last parameter, that is payment date of type date. All right, now let's write a SQL statement to update the invoice with the given ID. So update invoices. Let's give it an alias. Here we set i.payment total to this payment amount parameter. And we also set payment date to this payment date parameter. And then we write a where clause where i.invoice ID equals this invoice ID parameter. Here we only want to update 2 columns because when the client makes a payment, we don't want to accidentally update the invoice number or total amount or the invoice date. We only want to update the payment total and payment date columns. Okay. All right, let's go ahead and create this procedure. Here's the generated code. Beautiful. Let's go ahead. Done. Now let's call this procedure. So I'm going to call it right here. Let's set the parameters 2 for the invoice ID, 100 for the payment amount, and let's say 2019, January 1st for the payment date. Let's execute this. So this generates a call statement like what you see here. Now let's go back to our invoices table and verify that our invoice was updated properly. Here's invoice number 2. And as you can see, the payment total is set to $100. Beautiful. But what if we pass a negative value when calling this procedure? Let's execute this statement and see what happens. Back to the invoices table. I'm going to refresh. You can see we have stored minus $100 in the payment total column. And that is not good. We shouldn't store invalid data in our database. So let me show you how to validate the arguments that we pass to this store procedure. Back to our procedure. Before our update statement, we're going to use an if statement to validate the payment amount parameter. So if payment amount is less than or equal to 0, then here we should use the signal statement to signal or raise an error. This is like throwing an exception in other programming languages. So we type the signal keyword followed by the SQL state keyword, and then a string literal that contains an error code. Where do we find the error code? If you search for SQL state errors, you can find the complete list of these errors. Now here we have different pages for viewing the complete list. I personally don't like the one on oracle.com. It's poorly formatted. The one on IBM.com is better. Let's have a look here. The first 2 letters specify the class of the error. For example, 22 represents a data exception. Most of the time in store procedures, we want to deal with out-of-range values. And there is a standard code for that is 22003. Let me show you. So I'm going to search for 22003. These are all the errors in the category of data validation. So 22003 is the standard code for a numeric value that is out of range. And that's exactly what we want. So back to our procedure. Let's set the error to 22003. Note that this is a string, not a number, okay? So this is how we can signal or raise an error. Now we need to terminate this statement with a semicolon. Here we can optionally set an error message, and this helps the caller of the procedure identify why something failed. So it's a good practice to set a descriptive message here. So after the code and before the semicolon, we type set message underline text equal to, let me break this down to multiple lines. That's better. So let's type a meaningful error message here like invalid payment amount. Okay. Then we terminate this statement with a semicolon. And finally, because we have used the if statement here, we need to terminate this block using and if. So this is how we can validate the parameters of our store procedures. Now let's test this. First, let's apply the changes. All right. Beautiful. Now back to this other query window. If we call this procedure with an invalid payment amount, we get an error in the output window. So it's a good practice to check the parameters of a store procedure before making any changes to the data. But of course, too much of a good thing is a bad thing. If you write too much validation logic here, your store procedure will end up looking very bloated and it will become hard to maintain. For example, here I'm not going to check to see if this parameter is null, because the payment total column doesn't accept null values. So if you pass null to this procedure, MySQL will automatically signal this error. We don't have to do it. So keep your validation logic to the bare minimum, the absolute essentials. You should do a more comprehensive validation in your application at the time you receive input from the user. It's much faster to detect and report these errors in the application before hitting the database. Do parameter validation as the last resort in case someone directly calls your store procedure without using the application. You have learned how to use parameters to pass values to your stored procedures. But as I told you earlier, we can also use parameters to return values to the calling program. So in this demo, let's create a new procedure. Get unpaid invoices for client. Here we need a parameter called client ID of type integer. Now our query is going to be pretty simple. Select, let's say we only want to get the count and the sum of all these unpaid invoices. So sum of invoice total from the invoices table, where i.client ID equals to client ID and payment total equals to 0. Let me put this on a new line. That's better. Let's go ahead and create this procedure. All right, done. Now let's quickly test it before going any further. So here it is, get unpaid invoices for client. In this pop-up, I'm going to pass 2 for the client ID. We don't have any unpaid invoices for this client, so let's try client number 3. All right, that's better. So we have a total of 2 unpaid invoices, and the total amount is $286. Now, we can also receive these values through parameters. So back to our procedure, we need to add a couple more parameters here. Invoices count. We can use tinyInt or int depending on the possible number of unpaid invoices. For simplicity, let's just go with int. We also need invoices total. That is going to be decimal of 9 and 2. Now, by default, all these parameters in a store procedure are input parameters, which means we can only use them to pass values to our procedures. So here we need to prefix these 2 parameters with the out keyword. And this marks these parameters as output parameters. So we can use them to get values out of this procedure, okay? Now we need to make a slight change to our select statement. We need to select these 2 values into invoices underline count and invoices underline total. So we're reading these values and copying them into these output parameters, okay? Now let's apply the changes. Good. And then call this procedure again. Now we get 3 parameters here. The first parameter, client ID, is an input parameter. The other 2 are output parameters. So let's pass 3 for the client ID and execute. We get the same result as before, but look at the code that is generated here. First, we have to define 2 variables, invoices count and invoices total. These are what we call user-defined variables. A variable is basically an object that we can use to store a single value in memory. Now, to define a variable, we need to prefix it with an @ sign. So here using the set statement, we're defining two variables and initializing them to 0. Then, when calling this procedure, we need to pass these variables. So our first argument, 3, is the client ID, and the other arguments here are the variables that we defined earlier. Now, after we call this procedure, we need to use the select statement to read these values and display them here. So as you can see, using output parameters requires a little bit more effort to read data, and I would suggest you avoid them unless you have a valid reason for using them. In the last lecture, you learned how to define user variables. These are the variables that we define using the set statement, and we prefix them using an @ sign. Quite often we use these variables when we call stored procedures that have output parameters. So just like what we did in the last lecture, we pass these variables to get the value of output parameters. Now, these variables will be in memory during the entire client's session. When the client disconnects from MySQL, these variables are freed up. So we refer to these as user or session variables. We define them using the set statement and we prefix them using an @ sign. Now in MySQL, we also have another type of variable called local variable. And these are the variables that we define inside of a stored procedure or function. We'll look at functions soon, so for now, don't worry about them. Now these local variables don't stay in memory for the entire user session. As soon as our stored procedures finish execution, these variables are freed up. Quite often we use this type of variables to perform calculations in our stored procedures. Let me show you. So I'm going to define a new stored procedure. Let's call this get risk factor. Now let's make up a business rule. Let's say risk factor equals to invoices total divided by invoices count multiplied by 5. This is where we use local variables. So we can define these local variables in our procedure. And with this, we can easily implement this formula. Let me show you. First, we need to declare our variables on the top right after the begin statement. So we use the declare statement to declare a variable. Let's say risk factor. Next, we need to specify its type. Let's say decimal of 9 and 2. So as I told you before, that means a number with a decimal point. Here we can have a maximum of 9 digits and 2 digits after the decimal point. Now here we can optionally give this variable a default value. Otherwise, it's going to be null. Okay. Now we need 2 more variables. Invoices total. This is also going to be decimal of 9 and 2. Here we have a syntax error because I forgot to add a semicolon here, right? Now, I'm not going to give this second variable a default value because we're going to set it using our select statement. You will see that in a second. Finally, let's declare another variable, invoices count, and this is going to be an integer, right? Now let's write a select statement to set these 2 variables. That is very easy. So select count of everything and sum of invoice total from the invoices table. Now we need to read these values and put them into these variables. So that's where we use the into statement, into invoices count and invoices total. So here we have 2 variables which correspond to these 2 values that we select here. Pretty straightforward. Now let's terminate the statement with a semicolon. Next, we need to calculate the risk factor. So we use the set statement to set the value of a variable. Set risk factor, invoices total divided by invoices count. Let me zoom out a little bit. That's better. And multiply this by 5. Once again, let's terminate this with a semicolon. Finally, we're going to select this risk factor. So this is how we declare and use local variables in stored procedures. As I told you before, these local variables are only meaningful in our stored procedures. So as soon as we declare them, they become available. And as soon as we finish executing the stored procedure, they go out of memory. Okay. Now let's create this procedure and test it. So apply, good. And finally, here in the navigator panel, let's execute this stored procedure. And this returns 777.75. So far, you have seen many of the built-in functions in MySQL. You have seen the aggregate functions like min, max, and so on. You have also seen the functions for working with numbers, dates, strings, and so on. In this tutorial, I'm going to show you how to create your own functions. Functions are very similar to stored procedures, but the main difference is that a function can only return a single value. So unlike stored procedures, they cannot return result sets with multiple rows and columns. So in situations where you want to return a single value, you can create a function. A good example of this is the calculation of risk factor that we did in the last lecture. So in this lecture, we're going to create a function for calculating the risk factor per client. So let's close the stored procedures folder, right-click on functions, and create a new function. The syntax for creating functions is very similar to the syntax for creating stored procedures. So here we have create function. We give it a name like get risk factor for client. Here in parentheses, we define our parameters like client ID of type integer. Next, we have this return statement. This is one of the main differences between functions and stored procedures. And this specifies the type of value that this function returns. So we can have int or integer or any other data types that we have in MySQL. Now, right after the return statement, we need to set the attributes of a function. Every MySQL function should have at least one attribute. These are the attributes. One is deterministic, which means if we give this function the same set of values, it always returns the same value. This is useful in situations where you're not going to return a value based on the data in your database because the data can change. A real-world use case is a function that calculates the shipping or tax for an order. You might have a formula based on your business rules. Let's say the tax should be 10% of the order's total. So the function receives the order total and returns the tax amount. It's deterministic, which means it always returns the same output for the same inputs. So here's one attribute. Another attribute is reads SQL data. And this means that you're going to have a select statement in your function to read some data. We also have modifies SQL data, and that means you're going to have an insert, update, or delete statement in your function. Now, you can have multiple attributes here. For example, if your function both reads and modifies data, you can have both these attributes here. Now, back to our example. In this example, our function is not going to be deterministic because if we give it the same client ID, it may return different values. 1 second later, the client may pay some of their invoices, so the risk factor can change in a second. So we remove this attribute. We're going to read data using a select statement. So I'm going to keep this attribute, but we're not going to modify anything. So I'm going to delete this attribute. Next, we have the begin statement. Here we write our select statements. And finally, we should always return a value. So to save time, I'm going to copy some code from our get risk factor procedure that we created in the last lecture. So let's go back there. We're going to bring all these variables. We're going to bring our select statement as well as the formula for calculating the risk factor. So copy back to the new function. Let's paste them here. Now we need to change the select statement and add a where clause here. So where, here we should give this table an alias like I, where I.clientID equal to the client ID parameter of this function. Next, we calculate the risk factor. And finally, using the return statement, we return it. So risk factor. That's how we create functions. Let's go ahead and click on apply. All right, now let's apply the changes. Beautiful. Now we have a new function. We can use this function in our select statements, just like the built-in functions in MySQL. So we can select the client ID and name columns from the client's table. This returns these two columns here. Beautiful. Now we can add a third column, and here we can call our new function, get risk factor for client. And as the argument, we pass the client ID. There you go. Now we can see the risk factor for all these clients. Some of them don't have a risk factor. We see null here because these clients don't have any invoices. So back to our function where we calculate risk factor, we get the invoices total, which is the count of everything. This is always 0 or greater. Now the second value here is invoices count, which is the sum of invoice total column. Now if this client doesn't have any invoices, sum is going to return null. So 0 divided by null produces null. Here we can use the if null function. So if risk factor is null, we can return 0. Okay, let's apply the changes. Beautiful. Now back to our query. Let's execute this one more time. Now instead of null, we have 0. Also, note that the name of this column is based on this function call. You want to rename this to something meaningful like risk factor. That is better. So this is how we create and use our functions. Also, similar to views and stored procedures, it's a good practice to save your functions in SQL files and put them under source control. I already covered that before, so I'm not going to repeat it. And finally, we can use the drop function statement to drop a function. So we type drop function. Optionally and preferably, we can type if exists, and then we type the name of the function, get risk factor for client. As you work in different organizations, you will realize that different people adopt different conventions, and quite frankly, everybody likes their own conventions. Some people like to prefix their functions with fn, or their stored procedures with proc, with or without an underline. Some people like to use camel case when naming their functions and stored procedures. For example, proc get risk factor. So with camel case, we capitalize the first letter of every word except the first word. There are other people who think this proc or any other prefix is unnecessary, so they prefer to call this procedure get risk factor. In this course, I told you to use an underscore, so we call this procedure get underline risk underline factor. Again, some people love this, some people hate it. Don't waste your time arguing about these things. There is no such a thing as the very best naming convention. You can never make everybody happy. By the same token, there are different conventions for changing the default delimiter. Some people like to use double dollar signs. Other people like to use double slashes. My advice to you is wherever you work, adopt the convention that is already there. Don't try to reinvent the wheel because most of the time you'll be working on applications that are already built. They might be a few months or a few years old. If you want to argue with your teammates about the naming conventions that they have used and say, hey, I'm using this because Mosh told me to do so. This is not going to work, my friend. I'm telling you. So stick to the conventions that are already there. And if you're building a new project from scratch, then you can adopt the conventions that I've shown you in this course, assuming that you like them. If you don't like them, that's perfectly fine. The bottom line is whatever convention is there, stick to it.